Greetings. This is Nate's Assignment 6, Problem 1, Section 1. We are given that x and y have a joint density function and is somewhat defined by the f of xy over the function of xy equal to 1 plus xy over a. And a is further constrained by the fact that the absolute value of x is less than 1 and the absolute value of y is also less than 1, and everything is 0 otherwise. In finding a, item 1, we take the double integral of the quantity 1 over a times the quantity 1 plus xy dx dy. And actually that sort of breaks down into arriving at 4 over a, and consequently a is equal to 4. So the new function f of xy is equal to 1 plus xy over 4. Part 2, where we're asked to find the expected value or mean of xy, which is equal to the double integrals of minus 1 to plus 1 of xy times 1 plus xy over 4, which breaks down to equal 1/4 the quantity of the double integrals from minus 1 to 1 of xy dx dy plus the same double integrals of x squared y squared dx dy, which totals out to 1/9. We look at the expected value of x being equal to the double integrals of from minus 1 to plus 1 of x times 1 plus xy over 4, and we see that that translates out to equal to 0. Therefore, the expected value of xy is not equal to the expected value of x and y. Therefore, the x and y are uncorrelated. They are not, that's a not sign, uncorrelated. Correspondingly, in 3, we look at the expected value of xy not equal to x times y, which implies that x and y are not independent. I'm sorry for the pronunciation error. That's the end of section 1. Greetings, everyone. This is the continuation of homework assignment 6, problem 1, the second and final section. Here we are asked to find the joint density of x squared and y squared. We proceed initially by setting z equal to x squared and and w equal to y squared. Then we have the Jacobian equal to the matrix of 2x, 0, 0, and ty, and 2y, my gosh, I can't speak, equal to 4xy, which basically has z equal to s squared and w equal to y squared. When z is greater than 0, less than 1, or w is greater than 0, less than 1, the Jacobian for I equals 4 times the square root of z times the square root of w for the 4 items, or component items. Starting out with f z of w is equal to the function z of w, which is equal to fxy of the square root of z, comma, the square root of w over the absolute value of the first Jacobian, plus the function fx of y over the second root minus the square root of z, comma, the square root of w over the second Jacobian and/or root, plus the third, which is the square root of z, comma, the square root of minus w over the third Jacobian, plus the absolute value of the third Jacobian, plus the function fxy of the quantity minus z, comma, minus the square root of z minus the square root of w over the fourth Jacobian. When we evaluate, we end up with 1/16 times 1 over the square root of z times the square root of w times the overall quantity of 1 plus the square root of z times the square root of w plus 1 minus the square root of z, square root of w, plus the quantity 1 minus the square root of z, the square root of w, plus 1 plus the square root of z, the square root of w. These are the four roots, which basically, when simplified, come down to equal 1 over 4 the square root of z times the square root of w. When z is less than 0, or, that's the or sign, z is greater than 1, and, that's the and sign, the quantity of w less than 0, or w less than 0, or w greater than 1, and the total equal to 0. We have fz of w, the quantity z of w, equal to 1 over 4 the square root of z times the square root of w. And in this instance, the constraints are that z is greater than or equal to 0, likewise w. The other constraint for this particular function is that at 0, it is 0 otherwise. And correspondingly, we have the same type of situation set up for fz of z, which is equal to 1 over 2z, the square root of z, with z greater than or equal to 0, less than 1, and 0 otherwise. In this particular instance, we can also say that f of w is equal to 1 over 2 the square root of w. And this is the case when w is greater than or equal to 0 or less than 1. For the function cw of z and w equal to fz of z times fw of z, which yields, therefore, that x squared and y squared are independent. Thank you.